RASS it's a summer internship, but it's more than an internship. We're a bunch of undergraduates and graduate students learning more about how robotics are used in the real world and how robotics are used specifically at Los Alamos National Laboratories.
I don't think there's an internship like this where you're working with a team of all interns and building something from scratch. It's not just an exercise, it's for an actual client. So I think that's pretty special.
Something that's really cool about this internship is just the place. Los Alamos is a national lab.
Just the surrounding area, like the scenery, is just really, really beautiful.
Like I wake up and there's a beautiful sunrise.
Going on long hikes.
Everyone got pretty close together. We're hanging out with each other on the weekends.
It was a good summer.
The RASS application process is competitive.
We got over 800 applications.
We're not just looking for top talent, we're looking for top talent with grit.
This is the high explosive project, which we have coined Meow. So we're mixing explosives with OmniRAM. Wow. Yeah, we had to emphasize the wow.
We are the antenna tuning project.
We're workshopping a better name.
We are the LiDAR team, working as a part of the Robotics Augmentation and Novel Applications team.
Our team name is the SLS 3D Printing Parts Cleaning Project, or we call it SLS-PC for short.
We started with basically nothing except a robotic arm.
We definitely spent a lot of time working on the design.
We did a lot of drawings just on paper, trying to pick apart our design to find the best one.
Started on prototyping, so designing for our algorithms and writing code to test different cases and do some experiments. So getting into it pretty quick.
And we've gone from zero to almost a fully automated system, and hopefully an automated system by the end of the summer.
You're thrown into an environment with students you haven't met before, a project that you're not super familiar with, and have a very short time frame to complete it.
The experience that you get in RASS is not like any traditional summer school. Every day poses a different challenge.
Okay, so this is week 4, right? Week 4 or 5?
Gosh, 4 weeks we've been working. We're meeting with our client for the first time tomorrow. And they may look at everything we've done and be like, that's bad.
I've been trying to do one thing today, all day today, and I think I got halfway there.
I got less than halfway through the thing I was trying to do, probably.
A lot of things have worked, but there's a long way to go.
There was a moment where it was kind of integration hell and stuff wasn't working, and it was like, this is our powder dispenser. We designed our own dispensing mechanism for that. And then we also have a peristaltic pump to dispense the liquid. Our analogs are maple syrup and powdered sugar. The robot arm does most of it, and then a Raspberry Pi in there controls all the other stuff.
And we got it moving, and we have all the pieces. We just have to put it together over the next 2 weeks.
We tested our system today. It was really good, and our system worked pretty much as expected. So this is the antenna, this is the gimbal that has 2 degrees of freedom. This motor here controls polarization.
Overall, I think our system is definitely working. It's doing what we think it should be doing, and we just need to put in those last few details to make it really good.
Now that we finished with all the hardware, I get to fully focus on the software side of things, which is kind of what I've been waiting for the whole summer. So I'm excited to dive into that.
You have to prototype in 10 weeks and you have deliverables. It's really quite stressful to get a prototype that looks nice, that works as it should, and that meets the client's requirements.
The goal of RANA is to take these Boston Dynamics Spot robots and the mobility platform that they provide and essentially attach payload to assist with RCT radiological scanning.
We have a very good little cohort over here. Eric has said 370 dad jokes so far this summer.
Still brushing up on my pun skills, It is very cool seeing the dog walk around. But yeah, getting to run your own code on it and see it trace its path through a building while it's moving around is really cool.
You cannot make a system work unless you really understand what's going on.
Essentially, this is a cobot, right? So a cobot is a type of robot that humans can work with collaboratively, hence cobot. Actually, the robot is doing our cleaning routine right now. We're still assembling it because the parts just came in today. So we're gonna do an unboxing video. This is our electrical enclosure. This is the greatest day of my life.
There's been like quite a few roadblocks and errors that I've been running into in getting the environment set up and trying to get the gripper mounted to the robot. I do feel confident that we'll be able to deliver to our customers like the kind of system that they want.
It's been really interesting to see how the RASS program has kind of grown up over time.
And this year we're really focusing on that collaboration across the laboratory and that networking aspect for the students.
Talked to a lot of very interesting people from all over the lab, and our program ran successfully the whole time. I'm overall happy with how we did.
I appreciated the amount of teamwork that this division has and the program has.
It's a great group, so I've been really happy with the summer.
It's been really nice to be able to share ideas back and forth and then find out a compromise somewhere.
Getting 10 weeks to hammer out like a big project with a small team, that's something that you don't really get, especially like a interdisciplinary team.
I think I'm taking away a great sense of pride for not just the work that we've done here, but also the knowledge that we've gained and the experiences that we've had working as a part of RASS.